Hello, class, receiving students and teachers. Hello, Mr. Thank you. You may be seated. Now, recapping on our previous lesson, what did we look at in our previous lesson? Can anybody tell me? Receiving students, you may also tell your teacher. Let's hear from Lisa.
Chemical changes in our environment.
Chemical changes in our environment. Very good. What did you look at when you saw chemical changes in our environment? Jubilee, would you like to help Lisa answer that question?
Rotten food. Rotten food.
Rotten food. Good. You looked at rotten food. You did go outside to, the model class went out to do the excursion outside to find chemical changes occurring near their classroom. And some of those were already discussed in our previous lesson. In today's lesson, receiving teachers, we are still on the same strand, the sub-strand, and the learning outcome, which is 7.3.2, and unit 5, that is on changes of matter. Our topic for today is about chemical changes, and of course this is lesson number 71, about chemical changes. Today we will still be looking at chemical changes. Receiving students and class, we will still be looking at chemical changes. Before we look at that, I would like you to copy this table down because we are going to be doing some experiments. So do copy this table down into your books as quickly as possible. Okay, receiving students and class, by now you should have copied down those two tables. Now, the first table, we will get straight into our activities. In the first table, this is what you are going to be doing. You will be observing the experiments, and then you are going to be writing beside those your descriptions and writing simple word equations. Now, we are going to do the first one as an example, and then followed by the other two. You observe and watch what is happening. Okay, let's verbally do the first one up here. Now, let's do the common one that occurs in our homes. I'm sure this is a common occurrence that occurs, probably dinner time. Cutting a cow. Okay, so if we cut a cow, I would like you to think, if we cut a cow, describe your observation. What has happened after you cut a cow? And let's say the cow stays for 5 minutes. What do you think will happen? Can anyone tell me? You cut up a cow and you leave it for 5 minutes. What happens to the meat around the cow? Anyone? Receiving students, you may also tell your teacher. Let's imagine that you have cut a cow in half. And what happens to the inside of the cow? After 5 minutes, what do you think will happen? Momoru.
Juice will come out from that cow.
The sticky juice will come out from the cow. Okay, that's what she thinks. She thinks that the sticky juice will come out from the cow. Sticky juice comes out. What happens to the meat or the flesh of the cow rather? Shannon, after 5 minutes.
It will look white.
It will look white. The white part of the cow will still look white after 5 minutes, right? Cooper,
It will change color.
it will change color. Very good. It's going to change in color. Change color. It changes color. It changes color into a blackish purple. Blackish purple. It changes color into blackish purple. Okay, that's for cow. Now, when we write a simple word equation, what can we say about that? When we write a simple equation in words, what can we say? What has caused the cow to change color? What do you think has caused the cow to change color? Anyone? Receiving students, what do you think? Okay, you may tell your teacher. Now, let's hear from Walter.
Chemicals in the air.
Chemicals in the air. Okay, from the air, right? Air. So let's say air. Air. Air plus what will give that? Air plus the cow. Cow juice. Cow juice and also the flesh. Gives that blackish purple color. Blackish purple blackish purple color. So we can say that a chemical change has happened from the air reacting with the cow juice or the flesh of the cow. It gives that blackish purple color there. So from the air plus the cow juice or the flesh gives us that purple blackish color. Very good. Right. Receiving students and class, can you see that? Yes. For our first activity, that is what we are going to be doing. Something similar to what we have already or just did. Now, we are going to be doing mixing vinegar and baking powder, and you are going to observe what is happening, and then you will write something similar to like what we did with the cow. Is that clear? Very good. Okay. Now we're going to go through the first experiment. The first one is on. First one we have vinegar here, white vinegar. We will be using white vinegar and we'll also be using a baking powder. White vinegar and baking powder. So we will use white vinegar and baking powder for the first experiment. Now I would like you to describe your observations very carefully. With that, we will also be using a glass jar. Okay, you all ready? I would like you to watch very carefully. Now I will pour vinegar up to almost the brim of the container, and you watch. Okay, this is white vinegar. That's white vinegar. Now some of you cannot see it clearly, so, and we have our baking powder here. Okay, once I put that, a chemical change is going to take place, and I would like you to record. You describe your observations on what has happened. Receiving students, you do likewise in the table that you already copied down. Here we go. Okay, receiving students and class, can you see that? Should be able to see that clearly, that chemical reaction taking place. All right, write that down into your books. You describe your observation, what has happened when baking powder was added to the vinegar, white vinegar. Baking powder being added to white vinegar. Write your observations down. After you write your observations down, on the other side of the table, remember the equation we did with the cow, you write down a simple word equation. Okay, receiving students, what plus what will give what result? Class, you do likewise the same. Write it at the corner. In the box, rather. Okay, you got that down? Very good. By now you should have recorded that down. Okay, the next one, the next observation, we are going to be lighting a matchstick. Okay, this is common. It happens every day. You observe and then you write down your result. Okay, so you watch carefully and see what has happened. Then you write down your observation. Okay, there we go. The matches is now lighting. After it is blown out, what has the wood turned to? Okay, so you write down your observation. You got your observations down? After you write down your observations, you are going to do again a little word equation. What plus what gave that result? You got that? Very good. Now we will have model class, someone from the model class to describe what happened in the first experiment. Can anyone tell me what happened in the first experiment? Receiving students, you may tell your teacher. Can anyone tell me what happened in the first experiment when we added baking powder to vinegar? Lisa,
When baking powder was added to the white vinegar, it formed white bubbles.
it formed white bubbles. Very good. Now, who can write a simple word equation for that? Who has a simple word equation for that? Shannon. Shannon is going to write up the simple word equation for what Lisa had said. When baking powder was added to vinegar, it formed white bubbles. Okay, that is Shannon's word equation there. Receiving students in class, don't you agree? Simple word equation there. Baking powder plus vinegar gives us bubbles or white bubbles. Bubbles. Right, the next one. Lighting a matchstick. Who can describe that? What do we have for that? Class and the receiving students, Darren is going to come and write what he observed. What did you observe, Darren?
Matchsticks was bent and changed into black charcoal.
Okay, the matchstick was bent and changed into black charcoal, which is the ash. Charcoal and ash. Very good. Now, anybody has a similar answer to that? Receiving students, I hope you had similar answer to this. It occurs every day around us. Right, the word equation. Who has written down a simple word equation to go along with what we have written down up here? Anybody else? Receiving students? Okay, Sconti will come and write down the word equation up there. Sconti. Okay, Sconti has written down his word equation. His word equation is matchstick plus ashes matchbox, right? Okay, that's what Sconti thinks. It has a matchstick plus matchbox will give the ashes. Now, Evelyn, come and help Sconti to properly write down the word equation. Thank you. Now let's see our description. Matchstick was bent and changed into black charcoal. The matchstick plus fire from friction caused by rubbing it against the side of the matchbox gave fire, and eventually the matchstick became a charcoal. Okay, now for the next one, class and receiving students, you are going to be doing something similar, but you will do that for homework. I would like you to, what you are going to be doing is you will see nail rusting. Describe what is actually happening when the nail rusts. Okay, so that's nail rusting there. Then we have paper burning. Likewise, you write down what happens. And of course, burning magnesium ribbon. Now, for burning magnesium ribbon, I will quickly do that so that you write down your observations. All right, let's see what happens when we burn magnesium ribbon. Here with me I have magnesium ribbon here. These are the magnesium ribbon. Now, receiving students and class, be advised that once the magnesium ribbon is going through a chemical change, it is advisable for you not to look directly at it. Do not look directly at it, but you will be doing your observation. Okay, so this is the magnesium ribbon. We will burn magnesium ribbon. When it comes alight, once again, do not look directly at it. Okay, that is magnesium ribbon burning out. Good. Now I would like you to write down what you can observe after the magnesium ribbon has been burnt out. Now, receiving students, Glenda is going to help us do part of the description. She will describe what it looks like and how it feels, the magnesium ribbon.
It's gray and like a wire.
All right, very good. It is grayish in color and it's like a wire. Thank you, Glenda. Now, after you burn it, it should look something like this. This is the result when you burn out magnesium ribbon. When the magnesium ribbon burns, you should have something like this. That is what you are going to be describing. Okay, so this is what you are going to be describing. Right, that's for magnesium ribbon. That is for burning magnesium ribbon. Now, the next one, you can do this at home, and you describe the change or chemical change occurring when you fry egg. When you fry egg. You will also fill up that table. Right, 1, 2, 3, 4 of those activities will be done as your homework. Now, our summary for today. Our summary: chemical change occurs whenever there is burning, bubbles, and a color change. Okay, there are many ways in which chemical change occurs, but the main one, the ones that we looked at today are burning, bubbles, and a color change. Next one, chemical change can occur naturally or in the laboratory. Our key phrase for today, our key phrase is still chemical changes. Now the next lesson will be on types of energy and the materials needed for the next lesson, pictures and scrap papers. With that, thank you very much, class and receiving students, for your participation.